Hello and good morning everyone, and thank you for joining our VMware NSX webinar today. So we have Paul Mannerton here, who's Senior Systems Engineer from Avnet, who will be going through the webinar with you today.
Right, so hopefully everybody can see the slide deck, which is not in full screen mode, so hopefully you can see that. Just want to run through a few quick slides just to introduce NSX, and then we'll jump straight into a demo. Hopefully you've all come across the NSX in some shape or form, but it's worth talking about where this all fits in. So it's in the modern world, everything's virtualized. We come across very few greenfield sites these days, and one of the biggest challenges now is agility, getting things to market quicker ahead of competition. So this is a very disruptive technology. Everything is being transformed in some way. Most of the people on this call are probably sat at a computer. Some may be in from a tablet, but most of you are probably sat there with several devices around you, maybe even several computers around you. And this isn't unusual. NSX's aim is to make this whole virtualization ecosystem much more flexible, much more agile, and get things to market quickly. And a lot of big names are adopting this across a whole range of different industries and different product styles and different networking styles. So, you know, there's just a few of the customers. We're not going to go through those. And why? So why are we looking at this, and what's the big concern? One of the concerns about cloud generally that we come across and get asked about all the time is, what about security? And so we need to address that. What's driving that is obviously the well documented, without issuing any names, attacks on people's infrastructure. They're causing real problems, and we're getting denial of service attacks causing service outages, different applications that people are using. And you've probably heard the analogy before, but the analogy that we like to talk about is that of a castle and a hotel. So if you think about a castle, castles were built in the Middle Ages, and they were built to protect the inhabitants of the castle from attacks from the outside. So heavily fortified walls, drawbridges, very difficult to get into. But I'm a big fan of a series on Sky called Vikings. I don't know if anybody else has seen it. But there's a story there of them attacking and sacking Paris, and they did it by simply hiding somebody in a coffin and putting that coffin inside the walls. So it's the Trojan horse scenario as well. Once you get inside the castle, it's very easy to move about and do whatever you want to do, typically in most people's infrastructures. But if we move to the modern era, what we really want, we've got virtual machines in there, and we want to protect those machines in the way that a hotel does. So getting into a hotel is actually fairly easy. You're getting through the door. There's usually security in hotels and people on the desk. But once you're in the hotel, you can't really do anything without security, because all of the individual rooms in the hotel, which for this analogy is our virtual machines, are protected with a lock. So we can get into the hotel, but we can't get into the rooms and see what's around and route through the rooms very easily. And so the analogy here is it holds up pretty well. We've got this north-south traffic, what we call north-south traffic, that moves between the physical world and the virtual world. And yes, we're going to protect that, and we're going to give that some protection. And typically that's quite well protected in the physical world. Then we're also going to protect the east-west traffic, which is the stuff that once we're inside is moving within the virtual layer without going physical. And that's where NSX really comes in, bringing together that east-west traffic, that north-south traffic, and allowing us to protect at a very granular level that would be almost impossible to do in a physical world. It would be very expensive to do anyway, because everything would have to come outside of NSX, back in, outside of the virtualization, back into the virtualization layer through physical firewalls. So this is where we're headed, the software-defined data center. You've probably heard this ad nauseum, but what we've done in the past with VMware is we've managed to virtualized the compute layer. We've abstracted the compute layer so that we can do what we need to do. Virtual machines are very flexible. We can package them up and move them around and even move them live. We've also virtualized the storage with vVols and vSAN, where we can define at the virtual machine layer what we want to do with the storage, and thereby removing any reliance on having to do anything special or clever with the storage, although we still do some very clever stuff with storage. NSX takes that one step further and virtualizes and abstracts the network layer so that we can have control of the virtual machine within the network layer, within the virtualization layer, without having to do anything too clever at the network layer itself, the physical network layer. And it's all about making things faster. The demo I'm going to show you today is all me doing everything manually, but where this really comes into power is where we have automation on the front end, because we can automate all this and pull all this together without having any manual intervention at all. So that's the software-defined data center. It's all about programmatically creating networks, being able to do that automatically or very easily if we're doing it manually. So, sounds like a big change. Lots of people don't like change, understandably, I'm one of them, but it isn't. It's not a big change because we're going to bridge two worlds. What we're going to do is we're going to take the physical network and we're going to lay this on top of the physical network. We aren't actually going to have to change the physical network at all. So this is an abstraction layer in the true sense of the word. It's non-disruptive when we deploy. So we're going to put this in. It installs a small set of drivers into the virtualization host, and that enables this computing, this virtual network computing. And it sits on top of that physical layer. We don't need to do anything at the physical layer necessarily. And it gives us some distributed services. The main one that we're going to talk about today is the firewalling, which allows us to firewall individual virtual machines and isolate individual virtual machines. So it's very flexible, very quick, and very easy to deploy initially. There's a bit of planning that needs to go on, like any network. We get very good throughput rates because it's running inside the hypervisor. It's running as part of your hypervisor infrastructure, and we talked about east-west firewalling. This diagram is very good because it kind of models what I'm going to do in the demonstration. So we've got three what we call logical networks. So the whole point of this is that what we do is we model this abstraction on a thing called a logical network. So we take the physical and we just lay this object of a logical network on top. And in our demo we've got different logical networks defined, the web tier, the app tier and the DB tier. And what we're going to do is we're going to separate those out so that they can't talk to each other without going through a distributed firewall. And then they can go out to the outside world as well. And this is the strength because we can do all sorts of clever things, and we'll talk about that in the demo. And again, you know, it's all about, in the power of this is really about automation, but the value is there when we use it from a manual perspective as well. So hopefully most of you are familiar with a traditional virtual switch. If we're going to go out and firewall in a traditional virtual switch, we're going to have to hairpin. We're going to have to go out to the physical world and come back in again. Traffic that's on the same host will be okay, but anything that needs to be firewalled will have to go out because east-west traffic isn't by default firewalled. And then if we're going to layer 3 route, again, we're going to have to go out to physical. With a virtual network, we've already got these virtual networks. We've done some of this stuff with the standard networks. But if we're going to put in a logical network as well, then we need to get rid of that hairpinning. And if we put these distributed network services in, they don't have to go out to physical. We can firewall it inside the NSX virtual switch and deal with it that way. The clever thing is when we need to go out to another host in the virtualization, we can layer that logical network over the physical network using a thing called VXLAN and go out over that physical network and into the other host without having to utilize any special services on the physical network. This is the big flexibility. That also allows us to do site-to-site layer 2 networking. And then this can all be programmatically provisioned using a cloud management platform. And as you'll see within the demo, it can also be done using manual intervention. And then we can distribute more of those services, but the key thing here is that it's a simple IP backplane. We don't need anything else. We don't need VLANs, we don't need ACLs, we don't need any firewalls at that physical layer if we don't want them. We can just layer this on top and it takes care of everything for us. And that gives us this native isolation, even down to IP address isolation, so that we can build applications that can sit behind a NAT firewall on our hosts and be completely isolated, or we can isolate individual VMs on a network using firewalling. I didn't want to go through the deal, they were supposed to be hidden, sorry about that. And then we can then connect into, we can still bridge into VLANs. We use a thing called a bridge, but it's an NSX bridge that allows us to bridge our NSX network into our physical VLANs through our top-of-rack switches, etc. Again, non-disruptive. So, oops, sorry, clicked too many times. So why is it infeasible? It's infeasible because of that hairpinning. It's not going to work if we've got to put 40, 50 physical firewalls or 40, 50 sets of different rules in a firewall externally. That's going to be difficult. It's going to be complex to manage. It's going to pose a risk because we might get things wrong. So it's infeasible to do it in the physical world. And so microsegmentation, which you've probably all heard of before, comes into play here, where we bring that firewall inside the hypervisor and firewall at the individual VM level. I'm going to take you through all this stuff, so I'm not going to go through the slides. But there's a big difference between physical and virtual firewalls. Distributed firewalls allow us to do this at the individual virtual NIC basis. And the performance is pretty much the same with as it is with physical. So we're not hitting performance too much. And you'll hear this term a few times when you talk to people about NSX, this zero trust. Basically, we take a paranoid approach, because it pays to be paranoid in the modern world, of firewalling virtual machines off completely and only allowing through the stuff that we actually trust. And that's what we're headed towards. Now, the other thing is that we don't totally throw away any investment we've got in physical networking, because we can offload services to people like Trend, Palo Alto, Checkpoint, that allows us to offload things like intrusion protection, intrusion detection, content filtering, that kind of stuff can all go into the physical world as well and offload to that. Typically we'll use their appliances to do that. There's an example there of Palo Alto. And this is the real power, for me anyway, as an admin. The real power is the fact that I can intelligently group things together without having to think about it too much. So I can group things on their operating system type, on an application tier. I can group them using tags. I can set them up as services. And so we can do that, and it can be dynamically grouped. So a machine will automatically move in and out. One of the examples I've seen that I really liked was using Trend Micro. You can scan using introspection, so the same process as FreeShield Endpoint, which some of you may have heard of. We can scan the machine for a virus. If we find a virus, we can tag that machine as having a virus, and it will automatically then be moved into a quarantine network if we want it to be, where then Trend will look, see that that's moved in, and it will fix the virus, re-tag it as fixed, and then it will move back out onto the production network. And all that's the sort of level of automation we can achieve fairly easily. So we'll talk about microsegmentation in the demo. Why do you want SDDC? The rule's always been with virtualization, the more you virtualize, the more you realize the return on investment. So the more you invest, the bigger the returns. So typically the security of using this stuff can be a third of the cost. We reduce the time to market, the time to provision stuff dramatically, and we can, it says reduce, but increase the LTO by 80%. So this is the partner ecosystem. These are the partners that we're working with for that service offload. Most of the big networking partners appear there. So it's a fairly well-serviced ecosystem in terms of both security operations and application delivery. And there's support, therefore, for every step as you grow, as you change, as you evolve your IT infrastructure. There's people out there that can help you, namely Bytes. So that's the slides. What I want to do now is jump into the demo. So I'm just going to open my browser up again. And I knew that was going to happen, so I'll have to return to the lab. So while that's working, what I'm using here, what you'll see up at the top, I'm assuming everybody can see that. I'll ask Amy to shout if you can't for some reason. What you're seeing here is the VMware hands-on labs. I don't know who's familiar with those, but this is available to you at no cost. And the lab I'm using, you can actually go in and do this lab yourself. So my demo is something that you can go and play with in your own time and whenever you want to do so. So very useful. That's why I like to use these. So let's go through this. So I'm going to go back to my NSX home. Let's actually go to home and show you from the start. Hopefully many of you are familiar with this. This is the web interface for vCenter. This is the bad news or the good news, depending on your approach of it, is this is now the way that VMware are going, so everything will be in this. I understand that version 6.2 of vSphere will be completely web, and there'll be no C# client. They've announced end of life of that, so if you aren't used to it, get used to it. It's getting quite good. So what we're going to do is we're going to click on Networks and Security, which is where we administer the NSX stuff. So what that really means is NSX. The NSX home, we've got the usual Manage tab. We can see what's going on, but we don't need to. We're going to go into installation. So the way that we do this, the way that we install this, is we install this on a cluster-by-cluster basis, and across clusters as well, obviously. And each host has to have a small piece of code installed via a VIB, which you may be familiar with, into the host itself, and that provisions all of the NSX services that we need. It's a very simple install. It's done using a similar way to the way that we install other VIBs. We can use Update Manager, or we can do it live from here. Then we need to define some logical switches. So we have done here, we've defined a few. We've defined an app tier, a DB tier. This Edge Transit is simply a way that we get things out onto the internet, and a web app DB and web tiers. And those are predefined. Now, NSX Edge devices are virtual machines. They're not inbuilt, but they give us that perimeter and, as the name would suggest, that edge security. So there's a firewall in there, there's routers in there, there's NATs in there. There's also things for doing IPsec VPN. There's things in there for doing basic IDS and IPS and DLP, data leakage prevention. We'll come back to firewall. We can define services. I don't think we have any. Oh, we have got some defined on here. So there's some stuff here defined for IDS, and those services can be included in our security profiles. There's also a thing called a service composer, of which we've got a couple, and I'll take you through that in a minute. And then there's other stuff we can do that we would expect from networking, things like flow monitoring, activity monitoring, and trace flow. Let's just quickly look at the NSX Manager, because it's worth talking about that. NSX, the way that NSX works is that it has a manager that manages everything. It then has a controller, and we have to have multiple controllers, because if a controller dies and then we lose all controllers, then we do lose the network. So what we do is we build a cluster of controllers. It's an odd-numbered cluster to make sure that we avoid split brain. And they contain all the information about all of the virtual networks and logical networks that we need to worry about, as well as all the endpoints and the VTEP, what we call the VTEP, which is a VX tunneling endpoint, a VXLAN tunneling endpoint, so that we can have a picture of the network. They control the traffic, they control what's going on, which is why they're critical. So we always have a cluster of those. And if we go to monitor, we should be able to see the audit logs. If we've got to manage, actually manage was the one. Here's all the information about that manager and what's going on the network. So we can manage most things from here. So let's go back. And let's go through setting some of this stuff up. So the first thing is this service composer. So earlier on I set up a web tier application, and we'll go in and we'll edit that one. So we'll edit that security group. We give it a name. We can also define dynamic membership, and this is the power. We're not doing that here, but we'll go as if we were going to do it. We can say match criteria, any, so it would match any of those criteria. We can add a criteria, and you can see the things that we can check here. So computer OS, computer name, VM name. So we could say computer name contains web, and then anything with web in it would become part of the web tier, so that we can actually define security just by the computer name. We can say the VM name. We can do that by security tag, and we can do it by the entity name. I'm not actually going to do that. I'm going to delete that because I don't want to actually put that in, because this rule works currently. Now the other thing is that we can set up these security groups. So we've got a security group here that I've already set up. But for the minute, we'll just edit it. If I can, we'll set a new one up in a minute. I'll set a new security group up later. But we can select by cluster, logical switch, but more importantly down here, things like the virtual NIC, the virtual machine name. We can put a resource pool in this. We can do it by a distributed port group. We can put all of those into something. Now this one, as you'll see, is done by using virtual machines. So I've put 2 virtual machines into this web tier. We can also exclude objects. So we can go in there and we can exclude objects by various things. So I'll do it by VM, and I'll exclude a VM just to show you it works. So we'll exclude the Linux machine. So that machine is excluded from this tier. It'll never be included in this tier. Now we're ready to complete, so I can say finish, and we have changed that group, so that group's subtly different. So that's the service composer. That allows us to define these tiers. Very flexible, I think you'll agree. So what we need to do now then is we quickly need to look at the firewalling. So what we're going to do, what I've already done, is I've set up some rules for this 3-tier app. And in here we have a couple of rules that we've already included. I'm going to scale across. So this is a firewall. This is something that most of you are probably familiar with, is setting up basic firewall walls. So we're going to give it a name. We're going to talk about source and destination. So that first rule is the external to the web. So we're setting up a rule for external to web. So we've said anything that comes in externally will go to the web tier, but it's only going to pass through HTTPS. So we're firewalling for HTTPS. So we'll look at this now actually, and we'll click on that, and you see that we can define what services are going to be passed through. So if I wanted to do HTTP, I could add HTTP in there by searching, There's HTTP, and I can add that in as well. I am actually going to take that back out because we're only going to let the secure through. And then we're going to say for that allow, and it's going to do it via the distributed firewall. So the second rule is going to allow stuff to go from the web to the app. So we're saying from the web tier, allow it through to the app tier, and we've defined the source as the web tier group, so that service group that we defined earlier, to any destination within that app tier, but only for this service called My App. So if I go click on that, it's allowing through TCP 8443, and that's it. So that's actioning the fact that we're allowing port 8443 through from the web tier to the app tier. And the action is allow. So hopefully that makes sense to everybody. We haven't lost anybody. What we're going to do is we're going to add another one in here because we need to do the database. So I'm going to add below, I'm going to call it app to DB. Oh. Just show you how to set this up. So that will add a new section, hopefully. Oh, sorry, I put it in the wrong place. That was silly. Let's just add that in anyway. So that's added a new rule in that we can now go edit. So we'll call this, I'll take this rule out when we've finished anyway, app to DB. And then we can add a new source, so we'll see what we can add as sources. So we can add, as a source, we can add pretty much anything from a cluster, from a data center, from a port group, from an IP set, from a logical switch. So I'm going to select logical switch, and what we're going to do is, this is protected anyway, so this is probably something you wouldn't want to do normally, but we're going to say everything from the app tier, that's the source, and then the destination, we're going to add in the same again, from logical switch, and we're going to add that in as the DB tier. Now normally you'd want to do that on a bit more of a granular basis, but we could define here what service we're going to let through, but I'm just going to let anything through, and through the distributed firewall. So now what you'll notice is up the top here, I need to publish those changes. So I need to, in order to make those changes active, I need to say publish changes. And up here we should have, oh, it's just it reset automatically. What you should have seen there, sorry about that, is that I couldn't get through to this this database query, which is running on that multi-tier, but it's working now. And I will prove, I'll break it again in a second to prove that that actually does block it if I don't allow it. That's it working through, although actually it doesn't look like I've enabled the port, but it is working. So that's us micro-segmenting that application, stopping virtual machines communicating east to west, or allowing them to communicate east to west on a very secure basis. And we can, play with this as we see fit. That's actually me done a little bit ahead of time, but that's actually me done with the demo. If we can open up for questions, Amy, have you got any questions?
Yeah, sure. I'll just have a look 1 second. I'll just change it to my screen then. Thank you, Paul. So yeah, so if you do have any questions, there is a questions box which is just the right hand side of your screen. So pop them in there and I will read those out for Paul shortly. Okay, so there's a question here from Alex who's asked, can NSX support Cisco security group tags to work with products like Cisco ISE and the TrustSec model?
There is some integration with Cisco. I'm not sure how deep that goes, so if we could take that away, Amy, I'll double check on how deep the security tagging with Cisco goes.
Okay, that's no problem. So Alex, yep, we'll follow that up with an email or a call with an answer for you.
Is that it? We all still awake?
We'll just wait one more minute just to see if there are any questions, and if not, Alex has just asked again, any idea on the licensing model?
Yeah, okay, good question. Licensing model is fairly straightforward. Basically, we license it on a per CPU basis on the hosts. So it's fairly straightforward. You know, you're buying the same number of NSX licenses as you are ESX licenses. It makes it nice and easy.
Okay, thanks, Paul. So I think that's all the questions we have for today. So thank you, Paul, and thank you everyone for joining the webinar today. As mentioned previously, there will be a feedback form at the end, so if you could pop any feedback in there, or if you would like a follow-up call from Bytes, pop that in there, and one of our specialists will be in touch with you. Okay, so thanks again, everyone.
Thank you, everyone.